In this lesson, we're going to start our study of motion. We're going to be looking at motion in one dimension in a straight line. And to do that, we need to establish some of the vocabulary and terms that we're going to use. So let's get started. First, the vocabulary of physics. We're not going to start mechanics yet. Mechanics is the study of motion, force, and energy. We divide that into two branches. Those two branches are kinematics and dynamics. Kinematics is what we're about to do. We're going to describe how objects move. We're interested in describing that mathematically and graphically. Dynamics describes or deals with why objects move as they do, and it involves the force and energy part of it. We're just going to deal right now with translational kinematics, which means we're not going to have things that are rotating. They're only going to move in straight lines. And we're going to model them as point particles, so we don't have to worry about mass distributed across an area. We're just going to deal with things in one point. We will get rotational mechanics later, and we'll get mechanics later. But for now, we're just describing things in one dimension, so in a straight line path, either all in the x direction or all in the y direction, without worrying about why those things are behaving the way they are. To do this, we use measurements called vectors, and we reference those with a frame of reference, because when we're talking about position, distance, or speed, we have to make those measurements relative to something else. You have to compare your position to some other object in order to describe it. And if we're in motion compared to that object. And if you're moving, if you've ever been in a pickup truck or in a car or in a vehicle of any kind, you know you're at rest relative to the car when you're sitting in the seat, but you're in motion relative to the ground. So all motion is relative, and what we compare ourselves to, what we compare the motion to, that is what makes up our reference frame. When we specify motion, we need to include not only a distance, but also a direction. And this could be a speed, this could be a position, whatever. When we're describing things, we need both a distance and a direction. And measurements that include directions are called vectors. Now, I have this word magnitude here. Magnitude is the part of the measurement that tells me how big or how many or how much. It's the number part. But if I say 15 meters east, that is a vector because it tells me how far and in what direction. If I just say 15 meters, that's the magnitude. That's what we call a scalar. Masses are scalars. You can't give mass a direction. Mass just is. Time is a scalar. But things like how fast something is moving can be given as a vector. It can include a direction. We call it a velocity when it does. Now, position, distance, and displacement are three things that we use to describe motion or how something changes. So in order to do this, we need a point in our reference frame that we're measuring from. And we call that point our reference point or our origin. It's where all our measurements originate from. And it can be anywhere we want it to be, but once we assign it, we give it a value of 0 because it's 0 meters from itself. And then the distance and direction from the origin to an object gives us that object's position. So in order to know a position, we have to know distance and direction from a reference point. That means position is a vector, which makes sense because if I have a reference point here and I have another object over here, here's my reference point, it's 0, here's object A. It can be 10 meters here, or it could be 10 meters here. This is a different position. It has to be a vector because I have to give not only how far it is from the origin, but in what direction. Now this is two-dimensional since I have motion left and right and up and down, and we could have motion, for now we could look at motion up and down, or we could look at motion left and right. We're not going to combine those two yet. We will eventually. In one dimension, the direction can be indicated by sign, and that's because we could say to the right is positive and to the left is negative. So I could say that the position of object A is positive 10 meters, and you don't have to write the plus, it's understood. Now if I had something over here, I could say its position is, say, negative 6 meters. I do have to write the negative, but that's indicating to me that it's to the left of the origin. This would also work for vertical. We could call this way positive and this way negative. Now you can actually reverse your sign as long as you stay consistent, so it doesn't really matter which way you pick as positive or negative. Convention says to the right or up is positive and to the left or down is negative, but as long as you have established it and you've communicated it, you can pick whatever is convenient. The coordinate plane. So how do we draw these things? And I just had a picture of that. But the coordinate plane lets us graphically display position or displacement or even distance. So in one dimension, an object's position is given by its x-coordinate. And that's because here's our frame of reference. Our frame of reference is the xy axis. We're mapping something's position. And where those cross is our origin. And we generally say this is positive y, and this is negative y, and this is positive x, and this is negative x. And we're going to limit ourselves to either moving in this dimension or this dimension. So if I put an object anywhere on this line, its position relative to the origin is just equal to its x-coordinate. So if this is 5 meters, then we know we're 5 meters to the right of the origin. If this is negative 4 meters, then we know we're negative 4 meters or 4 meters to the left of the origin. Now, I've been using the term position, but I've also mentioned distance and displacement, and let's take a closer look at what's going on with those. Distance and displacement are both measurements that give us a length, but they do it in a different way. Distance is not a vector. It just tells me how far something has traveled. But displacement is a vector because it indicates a change in position. And this is kind of easy to see with a picture. I'm just going to draw my x-axis. Right, and so I have negative x is this direction and positive x is this direction. Now if I have an object that started right here, and let's say this is at 1, and it ended over here at say 5, its displacement is given by delta x. Now delta means change in, and it's always final minus initial, xf minus xi, except we're going to end up doing this with time, and so we might be looking at time 1 and time 2, or time 0 and time whatever, and so you'll see me write this equation as delta x equals x2 minus x1, or even delta x equals x minus x naught. And this was usually what I use, because this tells me I'm taking my position at some time minus my position that it had at at the beginning time, or the initial time, the time 0. But for now, here's an object and it started at position 1 and it moved to position 5. Its displacement, or its change in position, is positive 4 meters, and we get that by taking 5 minus 1, and that equals 4 meters. But if it had started at 1 and ended up over here at negative 2 meters, then we would say it moved this way, right? And to get that change in position, I would take negative 2 minus 1, which equals negative 3 meters, and that indicates that it is moved to the left 3 meters. That negative does not indicate a value, it indicates a direction. So that negative sign tells me this vector has a direction and it's 3 meters left of where it was. However, if I'm just interested in the distance the object moved, I drop that negative sign. And I would just look at this and say, well, it moved 3 meters. Okay. Now that's interesting because if I have something that, say, ran around in a circle, which I know is two-dimensional, its distance is whatever the length of this circle is. So if you run around the track once, you have a distance that you've covered of 400 meters. But your displacement is 0 meters because you're exactly back to where you started. So displacement is a vector and it includes direction. Distance is the length of a path and it does not include direction.